My beast has started barking. All right, so the three key words we looked at last time was current, voltage, and resistance. And we're going to go through them again, and we're going to do some more questions on them because these are really tough ideas. As I said last time, these are things that students who are older, you really, really, really struggle with. Because science, physics is a language, and you have to understand the difference. So, my children are about your age. Some of them are actually your age. Some of them are a bit older. And we were discussing this, and we were learning about this. And one of my children plays a game that involves strategy, Warhammer, with soldiers and things like that. And we were looking at, well, what do we mean by current? And the kind of conversation we was having is, if you think about games where you've got strategy, and if you've got a pathway and a set of soldiers walking down, the current is almost like looking at how wide this battalion, this group of soldiers is, or how, and how many of them pass a point in a given time. How many of them would pass, let's say, this point here in 1 second, or in 1 minute, or whatever unit you want to talk about. So current is the flow of these soldiers. Each individual soldier is a charge. Okay. Voltage is how much energy each soldier carries. It could be, you could look at how fast they're walking. The more voltage they have, the faster they would walk. The less voltage they have, the slower they would walk. Different ways of looking at this. So what you've got is an idea between what is current, the width of this battalion of soldiers, or how much water is flowing through a pipe. There's all these different ideas. The voltage is how much energy they got, or how fast they're running. Okay. Resistance is how easy it is for them to walk through there. So if all of a sudden you narrow this road, then you have this problem. It's hard for them to walk through. It's hard for them to fit through. So current is the flow of electric charge. Electric charge would be each one of these little soldiers. The unit, what you measure it in, is amps. And its symbol is I. Voltage, as I say, here's the push that moves the current. How much energy they got? Voltage is the easy one. The unit is voltage, V for volts. The symbol is V. So that's quite nice. Resistance is what slows the current down. It is measured in the units is ohms, the funny symbol. And the symbol is R. Okay. Ohm's law, and we're quite fast through this because we did it last lessons. Ohm law is V equals I, this is the symbol for current, times R. And in words, voltage equals current times resistance. Now, you can measure these in a circuit. An ammeter measures current. It must be connected in series. And I'm going to show you that in a diagram. We haven't really done these diagrams yet, but I'm going to show you. An ammeter would sit in series. It means it would sit inside the circuit. I'm going to put an electric motor there. I'm going to put a switch there. Next session, we'll be looking at drawing these. So an ammeter must be in series. It means one after another component. A voltmeter measures voltage. It must be connected in parallel. And parallel means like a train track. So if you're going to measure the voltage across the motor, it must be in parallel. I'm just going to put these words down. So I'm adding a little bit from, oh dear, that's huge. I'm adding a little bit more information than last time, but I'm also recapping what we did. So this is parallel. I'm typing parallel. And this is in series. Don't worry about it too much because we're going to do it in more detail. Okay. Now, we're not going to look at electromagnetism yet, but this is really good fun. We were looking at in 2 lessons. Fleming's left-hand rule is something I hope to talk about and maybe do. Okay, now, so in terms of questions, so that's all we're going to do. We're only covering 1 and 2. All right. In terms of questions, these are a lot exactly like last week's, but we add things to it. Okay, so you go through these questions, and the symbol I haven't talked about, which I did last time, I'm going to talk about it today. It's not on this list for some strange reason. Is the only thing I've missed out here is Q. This is the symbol for charge. We did that last week as well. This is its symbol. Its unit is C, the coulomb. And this is why I'm doing it again, because it takes so much time just to get used to these, right? And how you measure charge. The formula for it is Q, which is charge, is equal to I, which is current, times time. In words, this would be charge equals current times time. And time, the unit for time in physics, is always seconds. Okay? Now, here are your questions. All right? And that's what we're doing today. What I do suggest, I am recording this so you can look at this again, because this is about learning language. Okay? So, I'm going to